Hello, so this is the third video on probability for my Year 10 class. We are having a look then in this video about probability trees again, but this time it's with dependent events, and as you can see this one is the grade 5. Okay, so you need to be able to have a go at these, you need to be able to kind of do the best you can. You might not get it right all of the time, but actually with practice this one is not too bad. Okay. So, no starter today. I will be giving you letters throughout the video again, so that you can comment to me the word that I've given you. Let's have a look. So, probability trees. This time we've got, in a bag, there are 7 blue and 7 red sweets. Draw a tree diagram to show all possible outcomes when 2 sweets are drawn out and not replaced. Okay, so this is where last time you'd take one out and put it back in. This time you take it out and then you take another one out. Okay, so for the second event, there are a different number of sweets in the bag. So let's try. So there you go. So the probability of picking the second sweet is affected by the colour of the sweet that was first chosen. This is called dependent probability because it depends on the first choice. The probability of latter choices is affected by earlier decisions / outcomes. So, the tree. So we've got blue and red for my first event. So this bit is the same as last time. There were 7 blue sweets and there's 12 sweets altogether. So that's 7 over 12. And there are 5 red sweets and 12 altogether. Now, if I picked that blue sweet first time round, I could, next time round, pick out a blue or a red sweet. But my probabilities are different. If I've eaten one of those blue sweets, I don't have 7 blue sweets in my bag. I've only got 6 blue sweets in my bag. I also don't have 12 sweets anymore. I've got 11 sweets because I ate one. Okay, so it's going to be 6 over 11. There are still 5 red sweets in the bag. I didn't eat any red sweets. So there's 5 and there's still 11 sweets. Okay. Now, alternate universe, parallel universe, as I said last time, different choice was made at the start. I didn't pick out a blue sweet first time round. I picked out a red sweet. So this time round, I've still got 7 blue sweets in my bag, but I've only got 11 sweets. Sorry, blue and red. But I've eaten one of my red sweets, so I've only got 4 red sweets left and 11 sweets in the bag. Okay, so you might want to pause the video and go back through that and watch it again and just check that everything I've said makes sense. Okay, so moving on, looking at probability now. So this bit is the same. What it says is, notice how the denominator has changed to 11. This is because there are now only 11 sweets left in the bag. So we've got the probability of blue, blue, probability of blue, red, probability of red, blue, probability of red, red. So we do blue, which is 7 over 12, times blue, which is 6 over 11. We times them together, 42 over 132. Now you can see that will cancel. I don't cancel until the very last bit. That's me personally. You'll find some PowerPoints, some videos, they cancel them, so they're all in different bases, in different denominators, but I just find that makes things more complicated, so I leave it at that. Then we've got a blue and a red, excuse me, which is 7 over 12 times 5 over 11, which is 35 over 132. The next one then, red and then blue, so it's 5 over 11 times 7 over 11, which is 35 over 132. Then finally I've got red and then red, which is 5 over 12 times 4 over 11, which is 20 over 132. Okay, so that's drawing your probability tree for a dependent event, and then you could be asked questions about it. Okay, so they could ask you, so I've just moved all my, you can see they are the same numbers, I've just kind of squidged everything over. So, questions you could be asked. Find the probability of picking both blue. So that is where we've got a blue and a blue, which is just 42 over 132. Now I can cancel that down to 7 over 22. Both of those are divisible by 6, or 2 and then 3. Okay, so that's fairly straightforward. Find the probability of picking both the same. So that's where I get a blue and a blue, which is the 42 over 132, and the red and the red, which is 20 over 132. So if you add them up, and this is why I keep the denominators the same, if I'd have cancelled that down, that'd have been 7 over 22 plus 20 over 132. I don't want to do that, okay? If the bases are the same, if the denominators are the same, I can just add the numerators. I can, from here, now cancel that down, okay? They're both even, I just halved them. Okay, and then last question, I think, for this one, find the probability of picking exactly one red. So this way, you could get a blue first and then a red, which is 35 over 132, or you could get a red and then a blue, which is 35 over 132 again. So you add them up, which gives you 7 over 132, which cancels down to 35 over 66. Okay, so you can see, you know, kind of, once you've got these probabilities, this stuff is all the same as the last video. The only difference is these probabilities here. Okay, so that's the only thing that turns it in from being a grade 4 topic to a grade 5 topic. And what you've got to notice is this not replaced. Okay, so let's try another example. If you want to, pause the video now and try it first. I'm going to go through it because it's an example question, not a question, but you could pause it and have a go. Okay, so whether you pause or not, don't mind. We've got, complete the tree diagram, sorry, what is the probability that 2 socks taken out of the drawer are the same colour? Okay, so that was my question and my task to do. So, 8 green socks and 10 blue socks. So my first event, I could pick out a green sock, there are 8 of them, and there are 18 socks altogether. So that's 8 over 18 for the probability of picking out a green, the first time I pick out a sock. Then blue is 10 over 18. Okay, because there's 10 blue socks, 18 socks in total. Then it says, it's not replaced. So you take that sock out and then you keep it in your hand. A second sock is then taken out. So here, I've already taken out a green. I've only got 7 greens left in the drawer, and I've only got 17 socks left in the drawer. I have still got 10 blue socks in the drawer, but I've only got 17 socks. So that's my top line. My bottom universe, where I went blue first, I've now taken out a blue, so I've still got 8 green, but only 17 socks. And now I've only got 9 blue and 17 socks. Then we want the probability. Now you'll notice for this one, I'm not going to put the probabilities at the end. Now you don't have to get full marks in an exam unless it leaves you space to or directly tells you to. I think it's useful to write them all down. You don't have to. This is an example of when you can get away with not, because you've just got one question to answer from it. You can just pick out the questions you need. Okay, it saves the amount of work, but not by a huge amount. So we want the probability of getting a green in a green. So that's 8 over 18 times by 7 over 17, which is 56 over 306. Now this could be on a non-calculator paper. It's unlikely with those numbers to be on a non-calculator paper. Okay, but you just do long division. I did it by hand without using my calculator to get that. Then my probability of a blue and a blue, because I want the same colours, 10 over 18 times 9 over 17. I've already done the 18 times 17, which was the 306, so I didn't have to do it again. So it's not like I'm doing a huge amount of extra work. Okay, so that was 90. Then I want them both happening, so I just add them up, which gave me 146 over 306, which I halved to 73 over 153. So you'll notice these ones here would have cancelled. Actually, they would have cancelled to being over 153. But if I've done this one and I haven't done this one yet, I don't know what they're going to cancel to, so I may as well add them up while I'm big, and then especially, it will most likely be on a calculator paper, so it's relatively straightforward. Okay, so another question. This one is similar but slightly different. Okay, so in a village, 3/5 of the pensioners have had a flu jab. If a pensioner has had the flu jab, the probability of catching the flu is 1/30. If a pensioner has not had the flu jab, the probability of catching the flu is 7/10. So hopefully that's relatively logical. If you've had the jab, you're less likely to get the flu. Okay, obviously there's different strands of flu and that's why you could still get it, or there's different health conditions, which means the flu jab might not have taken properly, but which is why you could still catch it. So this time, instead of it being kind of directly dependent in terms of I've taken a sweet out of the bag so it's gone, it's now slightly looser and it's written in the question. You've got to interpret the words and think about what it means. So my options is either had the flu jab, which was 3/5, or not had the flu jab, which is 2/5. Obviously these guys, remember the branches when they're in their pairs have to add up to 1. So if we've had the flu jab, they can either catch the flu, which is 1/3 if they've had the flu jab, or not catch the flu, which is 29/30, because remember these two here in the pairs have to add up to 1. Or they could have not had a flu jab, which means the probability of catching the flu is 7/10 catches the flu, which means the rest, which is 3/10, doesn't catch the flu. The question then, what's the probability that a pensioner catches the flu? So that means I want the had the flu jab and catches the flu. So that's 3/5 times 1/3, which is 3/150. I've cancelled it down for this one, only because it makes the work easier in a minute. And then we could have had no flu jab and caught the flu, which is 2/5 times 7/10, which is 14/50. You can see here, I instead of building this one up to be over 150 by timesing it by 3, I just cancelled that one to be over 50, just because it worked nicely. I knew what the numbers were going to be because I'd seen the 5 and the 10 was going to 50, so I just did the work earlier. Okay, but now I'm going to add them up, which gives me, oh yeah, and I've cancelled it there, so it's 15/50, which cancels down to 3/10. Okay, so I didn't write that in there, so I missed a bit of working. 15/50, which you can divide the top and the bottom, the numerator and the denominator, by both 5, which gives you 3/10. Okay, so I've done 3 examples now, and I have not given you a single letter. I'm going to give you 2 now. I'm going to give you M for monkey and A for apple. So M-A, just because I'd completely forgotten to do that. I am now going to give you some questions to try on your own, and then I'm going to go through them. Okay, so try this one, pause the video, have a go. Notice I don't actually like the way they've done the tree diagram here. They haven't left you space to put the words in, like I have here. Okay, so just make sure whenever you draw your diagram, you leave your space to put the words in here and here. Okay, right, pause the video, have a go. Okay, so I'm going to do this one. Oh, yeah, Mum. What have I done? Oh, yeah, that's fine. Just don't want that. Or I want that bigger. Okay, well, I'm going to have to squint, I think. I have a bag of sweets. The sweets are toffees and fruit drops. There are 8 toffees and 6 fruit drops. So my first event, it could be toffee or it could be fruit drops. There are 8 toffees and 6 fruit drops, which means there are 14 sweets. So 6 fruit drops, 14 sweets. Okay, I have a sweet at random and my mate has one at random. Find the probability. So I take mine first because they're my sweets, then I let my mate have one. And they could have a toffee or a fruit. They could have a toffee or a fruit. Now if I took a toffee, there were 8 toffees, now there's only 7 toffees left. And there were 14 sweets, but I've eaten one, so there's now only 13 sweets. There are still 6 fruit ones in the bag. Parallel universe, I didn't take a toffee one first, I took a fruit one first. So now there are only 5 fruit ones. I'm being silly. So then there are only 5 fruit ones and there is still 8 toffee ones. Okay, so now I have to multiply. See, I've here got 4 questions with this, so I know I'm going to have to there you go. I know I'm going to have to do a little bit of work on this, so I'm going to work out all of my probabilities and then do any adding up later. Right, 14 times 13. I'm going to assume this is a calculator paper, and I'm going to do it on my calculator. Again, you could be asked to do that on a non-calculator. So 8 times 7 is 56, I know that anyway, and 14 times 13 is 182. 8 times 6 is what, 48 over 182. 6 times 8 is 48 over 182. And 6 times 5 is 30 over 182. If I wanted to check that these add up to 1, and they should do. So I have a toffee and my friend has, so that's me. I didn't label my events. Me, and that's my friend. Okay, so what's the probability? I have a toffee and my friend has a fruit drop. 48 over 182. Okay, so that was A, was 48 over 182. B, we both have fruit drops, so fruit drop and a fruit drop, 30 over 182. C, we both have the same, so the same would be that one and that one, because that's toffee and toffee, or fruit and fruit. So 56 plus 30, so that's going to be what, 86 over 182. Notice I've not bothered to simplify any of these fractions. It's probability, I don't have to. Okay, in an exam I might go back and simplify my probabilities at the end of once I've done everything else, but I don't need to. Okay, the exam paper will say they might give the simplified fraction and say or equivalent, which means as long as it's the same, worth the same, it doesn't matter. And then we end up with different sweets, so that means I could get a toffee and my friend could get a fruit, or my friend could get I could get a fruit and my friend could get a toffee, so that's those two. Oh, what's that? 96 over 182. Again, I can cancel that down if I want to. Okay, so hopefully you got that one right. Let me show you the next question. So, here we go. You can see when I'm doing this on a Sunday evening. Question 2. If I catch my bus, I'm going to give you a letter. I'm going to give you the letter G. G for gun. Huh. Right, question 2. If I catch my bus on time, the probability that I will be on time for work is 0.9. If I miss my bus, the probability is 0.4. The probability I will miss my bus is 0.3. Find the probability that... Okay, so I'm going to ask you to pause the video. You try it yourself. Okay, so hopefully you've tried that yourself. Let's go on here, and I'm going to really wish I could can't hide this, never mind, I can read it on my other screen. Okay, so this is a bit more complicated because we've got catching the bus and being on time for work. So catch or miss my bus. So the event is whether I catch or miss the bus. So if I catch the bus, okay, so I want the line. The probability I miss my bus is 0.3. Which means the probability I catch my bus has to be 0.7. Then the next event is whether I'm going to be on time for work or not. So arrive on time, so on time, or late, and then on time or late. So if I catch my bus, the probability I'll be on time for work is 0.9. Which means the probability they'd be late is 0.1. Remember, these pairs of branches have to add up to 1. If I miss my bus, the probability is 0.4. So we're still talking about if they get to work on time, so that will be 0.4 for getting work on time, which means that it'll be 0.6 for being late. Remember, these two numbers have to add up to 1. Okay, so now I'm going to do, there's several questions on this. Okay, so I'm going to work out all my probabilities. 0.7 times 0.979s are, what are they? 63, so 0.63. And 0.7 times 0.1, 0.07. Remembering when you are multiplying with decimals, like this, I go 7 9s 63, and then I've got 2 decimal places in my question, so I have to have 2 in my answer. 3 times 4 is 12, so that's 0.12. And 3 times 6 is 18, so 0.18. Again, you can do a quick check, they should add up to 1. Okay, right. What is the probability that I catch my bus and be on time? So catch and be on time, 0.63. What's the probability I will miss my bus and be late for work? 0.18. What's the probability I'll be on time for work? So on time for work is on time or on time. So that's the 0.63 plus the 0.12, which is 0.75. So that's 3/4 of the time they're going to be on time for work. That's, I mean, it's not great, but it's not horrendous. And then D, I mean, you'd get lots of late detentions if that was you getting to school. Anyway, I will be late for work. So late for work is this one and this one. So 0.07 plus 0.18. Now it should be the rest of that. So it should be 0.25. You can check my maths and check if it works or not. But it should be 0.25. Okay. I'm going to give you another letter now. I'm going to give you the letter N. Right. Looks like I've got 2 more questions for you to try. So, there are 10 pupils in my class, 4 boys, 6 girls. I need 3 of them to do a job for me. I select 1 person at random. No pupil will be selected twice. What is the probability that the people doing the job will be 3 boys, 3 girls? Ooh, tricky. Try it. Pause the video. Have a go. Okay, so what you should notice is for this one, I'm running out of space. Can I go sideways on this? I can. And how high up can I go? There we go. So what we should notice is I need 3 of them to do a job. Okay, so we've got boy, girl for the first student. Okay, so there are 10 pupils in the class. So the first one, it could be 4 out of 10 for a boy, which means 6 out of 10 for a girl. My second student then. If I pick a boy, I could, for my second student, pick a boy or a girl. Now, if I've already picked a boy, there are only 3 boys left in the classroom that I haven't picked, and only 9 students left I haven't picked. And there are still 6 girls out of 9 students. If, blah, 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 rewind time, I didn't pick a boy first time, I picked a girl first time. There are still 4 boys in the room, but only 9 students. And there's only 5 girls out of the 9 students. Okay, so that's my second pick. My third pick, you can see where this is going. Ooh, I'm running out of room. Okay, so boy, girl, boy, girl, boy, girl, boy, girl. Okay, so really running out of room. It's much easier if you plan ahead and plan your spacing out a bit better. Right, this time I've taken a boy, then I take a boy, then I take another boy, which means there's only 2 boys that I could have picked from out of 8 students in the room, because I've already picked 2 of them. Or I could have a boy, and then a girl. There are still 6 girls. Or I could have picked a boy, then a girl, and then there's going to be 3 boys and 5 girls. Remember, each pair adds up to 1 if you ever get stuck. Oh, where am I? I could have taken a girl, then I could take a boy, then a boy, which means there's 3 out of 8. Or I could have picked a boy and then a girl, which means there's 5 out of 8. Or I could have picked a girl and then a boy, which means there's still 4 out of 8 boys there. And there's only 4 out of 8 students there. Okay? So, what's the probability that the people will be doing the job will be 3 boys, 3 girls? Now, there's lots of calculations there, so I am not going to do them all. Okay, so this is one of those cases. I'm not going to work out 2, 4, 6, 8 different multiplications of 3 fractions there. Okay, I'm only going to do it for the ones I need. Okay, so I could get 3 boys. So 3 boys is that times that times that. Okay, so that's 3 boys, 4 over 10 times 3 over 9 times 2 over 8. Remembering, again, this could be on an old calculator paper. Actually, the numbers are not too horrible. So you can times in any order. You're doing your numerators and your denominators separately. So I would do my 4 times my 3 is 12, then times that by my 2 is 24. I think timesing by 2 is the easiest, so I'm going to leave that to the last. My denominator, I think 10 is the easiest to times by, so I'm going to do 9 times my 8 first, which is 72. I'm worried I made a mistake on one of the other questions earlier. Yeah. And then times it by 10 is that. Now I can cancel it down, but I don't need to. And then part B, I'm going to change the colour of my pen. So part B was girls, girls, girls. So it's 6 over 10 times 5 over 9 times 4 over 8. I'm going to do, because I know what numbers are going to come up, 5 times 4 is 20. So 20 is easy to times by. 6 times 20, well 6 times 2 is 12. Stick a 0 on the end. And then we've got the same, so 72 with a 0 on top. On top, next to it. I'm really worried now that I did 8 times 9 was 63 on one of these other questions. No? No, apparently I didn't. No, I did 7 times 9 is 63. That's okay. Just having a little worry I'd given you some silly advice. Okay, so there we go. One more question then. One more question. Alan is going to sit 2 exams. His performance is affected by his confidence. The probability he will pass the first exam is 0.7. If he passes the first exam, the probability he passes the second exam is 0.9. If he fails the first exam, the probability he will pass the second is 0.3. What is the probability that blah 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 blah? Pause the video, have a go. Okay, so last one. Right. I'm going to be reading it off my other screen. You've had a go already, hopefully. So, we're sitting 2 exams. And in the exams, it's either pass or fail. And that's the first exam. And then the second exam, he could pass or he could fail. Pass or fail. Okay. So, the probability you pass the first exam is 0.7, which means the probability he fails, remember these two have to add up to 1, is 0.3. If he passes the first exam, the probability he passes the second is 0.9, which means the probability he'd fail it is 0.1. If he fails the first exam, the probability he will pass the second is 0.3. Oh my goodness. And the which means then to fail, it's got to be the rest. Remember, in the pairs add up to 1, is 0.7. There's 3 questions then, so I am going to probably work these out because they're not too hard to work out. So 7 nines are 0.63. Remember, 7 times 1 is 7, so it's 0.07. 0.3 times 0.3, 0.09, and 0.21. Okay, what's the probability he will pass both exams? So, pass is that one, so A is 0.63. He won't pass either exam, so he will fail, and he will fail is that one, 0.21. He will only pass one exam, so that means he'll pass this one but fail the second one, or he fails and then he passes, so that's those 2 there, which is 0. My next letter is going to be U, 1, 6. Okay. So, those are my questions. That is dependent probability. Again, go on MyMaths, go on Maths Genie, go on Corbett Maths, anything like that to look up more questions if you think you need them. Contact me if you want to. If you need extra help on any of them. The last letter to make the word that I want you to comment on, show my homework to me so I know you've watched the video, is an M. Okay. So, by now you should have watched 3 videos from me for this week. So all I want is 3 comments. What were the words I asked you to comment to me for each video? So 3 words, 3 separate comments, however you want to do it. That's all I need. And all it does is just lets me know you've watched the video. Okay, you don't have to submit any of the work you've done, just those comments. Okay, so hopefully you should have all done that. That's all fairly easy and straightforward. It's just like sitting in one of my normal lessons. Okay, have a lovely weekend and have a lovely Easter holiday, because I probably won't be speaking to most of you again. So have a lovely Easter holiday, and I'll be preparing more work for you over the holidays for you to do afterwards. Okay, look after yourselves. I hope you're all well.